Hello everybody, welcome back. Today we're going to look at example 3 in section 1.4. We're going to determine the surface area of a right cone. A right cone has a base radius of 2 and a height of 7 feet. Calculate the surface area of the cone to the nearest square foot. So as you can see on your page, it is blank, so what you'll need to do is create a diagram. Just a little sketch. So you have your circle here. Looks more of like an oval, just to give you that three-dimensional look. And then you have your cone, looks like a triangle here. The radius is 2, so that's going to go to the center, and your height goes from the center to the apex. And you're going to see a variable s here. That s indicates slant height. All right. So you got to try to visualize cutting the cone in half through a diameter of its base, and this will produce two equal isosceles triangle. One that you see here dotted out, and there'd be another one coming here to the left if that's what it means by the isosceles. So what you're going to do now is you're going to use the Pythagorean theorem in a right angle triangle, and I call this ACD. The reason it's ACD is I guess they just had B over here, but they don't show that. That's not a big deal. So we're going to flatten that part out, and that's what it would look like if you cut it out. So what we're going to do is we're going to calculate the slant height using Pythagorean theorem. That's 2 feet for the radius, so it's going to be s squared equals 7 squared plus 2 squared. Hypotenuse would be the slant height, and these are where these values comes in. We square 7, get 49, square 2 and get 4, add them together to get 53, and take the square root of both sides to get the square root of 53. You can leave it at square root of 53. You don't have to calculate it to be 7 decimal, whatever. It's not necessary. Just plug it right in, and you can do that in at the end. Carry that value. So that value is in your calculator now. I'll show you what I mean by that tomorrow. Now you got to go get the surface area formula for a right cone. So the surface area for your right cone is going to be somewhere here. I lost it. I do apologize. There it is. Surface area of a cone. Should be on the previous page. But there it is. Pi rs plus pi r squared, no big deal. And again, that's on the formula sheet I gave you in class. So then we use pi rs plus pi r squared. R is the radius, s is the slant height. Slant height we already calculated at the square root of 53. Pi, we just leave it in. Do not put 3.14. Use the pi button on your calculator, please. 3.14 is an estimate. We want to use actually what pi is, so we use that pi button on our calculator. So it's going to be 2 pi multiplied by 2 multiplied by the square root of 53, which is 45.7422794. And then we take 2 squared, we get 4. 4 multiplied by pi gives us 12.566. And again, you could skip this step if you can do it. Just make sure you please put a plus in your calculator. The correct brackets, you should be getting 58.308.65011 ... That's what my calculator gave me. And if you look up, it says to the nearest square foot. So if it says to the nearest square foot, the decimal 3 rounds down to 58. And the surface area of a right cone is approximately 58 square feet. Make sure to put your units in your final answer and your units in your sentence if it's asked a question. And there is a question here. But it doesn't calculate, so you don't have to say that, but it's a good habit to get into. Check your understanding. A right cone has a base of 4 meters and a height of 10. Calculate the surface area of this to the nearest cone. So you're going to have to draw a diagram, and your answer is going to be approximately 186 meters squared. And there's your cone formula again. They're going to be all on one page. You don't have to memorize those. You just have to know how to use them. Okay? Remember, surface area is the lateral area plus the base area. Lateral area is the part that makes up the cone shape, and the base in this case would be the circle. Okay, that's where the formula comes from. Pi r squared is the circle on the base. Pi rs is the formula that's calculated to obtain the when you roll this out into the net, right? The part that rolls out. So first of all, I'll do a sketch diagram. It has a diameter of 10, so it's right across. Height we don't know, and the slant height we don't know. So we're going to calculate both of those. But we do know the lateral area of the cone. So the lateral area, as you see up here, lateral area is simply pi rs. That's just this part, so we don't need the base. So area of the lateral part is equal to pi rs. We know r, we're looking for s, we know pi. So we divide both sides by 5 pi. So we take the 220, divide it by 5 pi, and we get 14.0056499. So we round that to the nearest centimeter, which will be 14.0 or just 14. So it'll be the same thing. It's okay, right? All right. Then we have to determine the height. So we're going to use Pythagorean theorem. So height is here. We're going to use this part here. So it's not 10. We'll have to take half of that, which is 5, and the slant height. So that's going to create a another right angle triangle. So we have the slant height. So I'm going to bring that drawing in to dimension 9. There it is, just so you can see it. There's 5 because we just want it to A from A to B. All right. So slant height is what we calculated up here. So you'll notice I use the exact value. That'll be still in your calculator, so you don't have to write that all out. That's in your calculator, so you're just going to square that. You'll get 196.1578115. 5 squared would be 25. We'll subtract that from both sides. And we get 171.1578115. Take the square root of both sides, we get 13.08. And the answer said the height to the nearest tenth of a centimeter. So the 8 rounds the 0 up to 1, and we get a height of 13.1 centimeters. The height of the cone is approximately 13.1 centimeters in height. All right, and that's example 4. You have a question here that you can work on. It's you'll get approximately 16 3/5 of an inch. Not quite sure why they're using fifths of an inch. Usually, with, like I said, it's quarters or halves, eighths. It's usually a multiple of 2, but that's the book. Anyway, you can still work on the question and get that. And if you got a decimal, that's fine. It doesn't make a difference. And then you're going to work on page 34, numbers 4, 5, 7, 8, 10, 11, 14, 16, 18, 19, and 21. All right, folks, thanks for watching. That'll be the end of section 1.4. In the next video, we'll start with 1.5 volumes of right pyramids and right cones. Thanks again, and we'll see you next time. Thank you.